Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 6.2, Day 3. Today we are going to mix some of the stuff that we learned before as far as simplifying our radicals and multiplying our radicals and dividing our radicals with adding and subtracting radicals. Now, adding and subtracting radicals is going to be the new portion of this video. It's not going to, the rest of it's just a review. But as far as simplifying each radical, it's going to be exactly the same situation that we used before. So for simplifying problem number 1, I have the cube root of negative 135x to the third plus x times the cube root of 40. What we are going to do is we're going to treat each of these as independent problems until we have them as simplified as possible. So I'm going to simplify the cube root of negative 135x to the third by itself and worry about the x times the cube root of 40 later on, okay? So the first thing I need to do is take the cube root of negative 135x to the third. If you look at your cheat sheet, you will find out that negative 135 is not a perfect cube. However, if you start taking and dividing by the numbers that are smaller than it, you will find out that it can be broken into negative 27 times 5. Now, with our x to the third, we are looking for groups of 3, so that can just stay x to the third. Now, I'm going to continue with this portion before I start worrying about the other side. So I can circle negative 27 because that is a perfect cube. That will come out to negative 3, and I can circle x to the third, so I'll have 1x come out. I'll be left with the cube root of 5 underneath, okay? That is the farthest we can simplify the first portion that we just talked about. Now I'm going to simplify, so I'm going to put an addition sign in between where I first started working. I'm going to simplify my x times the cube root of 40. Again, 40 is not a perfect cube, but if you take and start dividing by the numbers that are a little bit smaller than it, that are perfect cubes, you will find out that it is divisible by 8. So 8 is a perfect cube. So I'm going to keep my plus sign. The 8 comes out as a 2. Now this x needs to come down. Then I have the cube root of what's left, which is this 5. Now from here, this is where things could get a little tricky for you. What you need to do is the radicals need to be 100% the same in order for us to add these two together. Don't necessarily write this down, but just pay attention to what I'm about to show you. If I had negative 3x plus 2x, I could add those two together because they're like terms. And that would give me a negative x as an answer. That's the same idea with our radicals. If they are exactly the same, so I have the cube root of 5 in both of my expressions here, then I can actually add those together. So those are going to be treated as like terms. So I'm going to take my negative 3x and my positive 2 and add them together to get me negative x. And then I'm just going to bring down the cube root of 5 one time. And that will be my answer. Okay? On to problem number 2. I have the square root of 32x to the fourth plus the square root of 2x to the fourth. So again, just like I did on the other problem, I'm going to go ahead and simplify the square root of 32. Well, 32 is not a perfect square, but it can be broken into 16 times 2. Now, x to the fourth needs to be broken into x squared and x squared, because with square roots, I'm looking for groups of 2. I'm going to circle my 16, which means it comes down as a 4. I'm going to circle my two x's, my two groups of x's, which means I can pull out an x squared. That is multiplied by the square root of 2. Now that I'm done simplifying that side, I'm going to go ahead and work with my other side. So I have the square root 2 is not a perfect square, and it cannot be broken up, so it's just going to stay 2. X to the fourth, though, can be broken up into x squared and x squared. I can circle my two x squareds, which means when I come down, I end up with x squared times the square root of 2. Now that my radicals are exactly the same, what I can do is take my 4x squared and my x squared, add them together, which means that I have 5x squared times the square root of 2. All right. Moving on to problem 3. I have the fifth root of negative 64x to the fifth minus x times the fifth root of 2. Here's a big hint for you. We know that we want our radicals to be the same. So what I'm going to look to do is take this negative 64, and I'm going to divide it by the number that's inside the other radical. That way, maybe it will give me a perfect fifth. If I do that, I will find out that negative 64 can be broken into negative 32 times 2. X to the fifth is 5x's, which is what we're looking for. Now I can circle negative 32. The fifth root of negative 32 is negative 2. I can circle my x to the fifth. That means I can bring out 1x times the fifth root of 2. Now if you look at the second portion over here, there's not anything I can do with this because 2 is not a perfect fifth. There's nothing underneath the fifth root sign that can be simplified. So I'm just going to keep that exactly the same all the way down to here. Now my radicals are exactly the same, so I can take my negative 2x minus x, which would give me negative 3x times the fifth root of 2. All right. Moving on to problem 4. I have 2 times the square root of 72x to the fourth plus 4 times the square root of 8x to the fourth. Now here, just keep your 2 out front as you're simplifying. So 72 is not a perfect square, but if you take and start dividing by all the numbers that are less than it, I'll find out 36 times 2 is what 72 can be broken into. I'm going to need x squared and x squared. I can circle my 36. So now I'm going to take the 2, multiply by 6, because the square root of 36 is 6, times x and x, which is x squared, times the square root of 2, because 2 is left over. From here, I need to multiply the 2 and the 6, so I'll have 12x squared times the square root of 2. At this point, I've finished simplifying that as far as I can, so I'm going to start working on my other side. I have 4 times the square root. 8 is not a perfect square, but 4 is, so I can do 8 times 2 times x squared times x squared. 4 is a perfect square, so I'm going to take 4 times the square root of 4 is 2. X squared, which means I can pull out an x squared, times the square root of 2. To finish simplifying that side, take the 4 times the 2, which is 8x squared, times the square root of 2. Now that my radicals are 100% the same, my x's on the outside are exactly the same, I can take my 12x squared plus my 8x squared to get me 20x squared times the square root of 2, and that will be my answer. All right. On to problem 5. Exactly the same idea that we've been using. I have the square root of 9x to the third. Well, 9 is a perfect square, so I'm going to leave it alone just for a second as I work with my x's. So I can take an x squared times an x to split up my x to the third. 9 is a perfect square, so that would be 3. The square root of 9 is 3. X squared is a perfect square, so I can bring out 1x. I'm left with just x under the radical. At that point, I'm done simplifying, so I'm going to start working on my other side. I have x times the square root of x. Again, there's nothing I can do with x times the square root of x. So if I bring it down one more time, now my radicals are 100% the same, so I'll take 3x minus x to get 2x times the square root of x. And I'm done. Okay? All right, 6. Here's where it'll change up a little bit. We're kind of mixing some of the older stuff with some of the newer stuff. Here, I have a multiplication problem. So if you remember from our first day, I'm going to take everything in the first radical times everything in the second radical. So I have x squared times x squared, which is x to the fourth. Whoops. Got to keep my radical. It'll be the square root of x to the fourth. I have y to the fifth times y to the seventh, which is y to the 12th. Now I need groups of 2, so it'll be the square root. From x to the fourth, I have x squared times x squared. From y to the 12th, I'm going to have x squared 6 times. So I have, that's 2, 4, 6, 8, 10, 12. Need to go ahead and circle any perfect squares I have. So I have 1, 2 x's, which means an x squared will come out. I have 1, 2, 3, 4, 5, 6 y's, which means y to the 6th will come out, and that will be our answer. All right. Now we're back to our addition type problems. So So I'm going to simplify my first radical first. Keep my 3x on the outside. Then I have the fourth root of. Is 16 a perfect fourth? Yes, it is. So I'll leave that as 16. Then I'll change my x to the 6th to an x to the 4th times x squared. Now here I can circle 16, which means I'll have 3x times 2. I can circle my x to the 4th, which means we have to multiply by x. Then I'll have the fourth root of x squared. If I take 3x times 2, that would get me 6x, times x would get me 6x squared, times the fourth root of x squared. Okay. Now that I've completely simplified my left-hand radical, I'm going to go ahead and work on my right-hand radical. On the right-hand side, 256 is already a perfect fourth. So if I leave that as 256, now I need to break x to the 10th into perfect fourths. There's 4, there's 8. So I've used 8 of my 10 x's. I'm left with 2 x's left over. We said that 256 is a perfect fourth. So if I pull out the fourth root of 256, I'll end up with 4. Then I have 2 x's, so it's x squared times the fourth root of x squared. Okay. Now that's completely simplified, so I'm going to just bring it down one more time to get it in line with my other radical. Now that my radicals are exactly the same and I have my x's on the outside are exactly the same, I can take 6x squared plus 4x squared to get me 10x squared times the fourth root of x squared, and I will be done. Number 8 is again a subtraction problem, so it's some of the newer stuff. So I'm going to go ahead and look at the square root of 200x to the fourth first. The largest perfect square that I can get out of 200 is 100. So I can actually split 200 into 100 times 2. X to the fourth can be broken into x squared times x squared. Okay. So 100 is a perfect square. That would get me 10. I have 2 x's, so I can get x squared times the square root of 2 because 2 is left over. So that is completely simplified. I'm going to go ahead and move over to my right-hand radical. So x times the square root. 72 is not a perfect square, but I can turn that into 36 times 2 times x squared. 36 is a perfect square, so I can do 6 times x again, which means if we look at that, without having to write a whole nother line, I can turn 6 times x into 6x squared. So now my radicals are exactly the same. I have x squared in both my numbers, so I have 10x squared minus 6x squared, which get me 4x squared times the square root of 2. And I'm finished with that problem. On to 9, again, it's a subtraction problem. So I'm going to work the left-hand side by itself, then I'll work the right-hand side by itself. Negative 32 is already a perfect fifth, so I'm going to leave it as negative 32. X to the 6th, though, I can take one group of 5 out, be left with 1x by itself. So negative 32 is negative 2. If I have 1x to the 5th, that means I have a single x brought out, times the square root of x, which is what is left over. So I have that fully simplified. I'm going to move on to my right-hand radical. So I have x times the fifth root of 32x. 32 is a perfect fifth. So I have subtract the fifth root of 32 is 2. So I have 2 times this x times the fifth root of x, because that was left over. So now my radicals are exactly the same. I have negative 2x minus 2x, so negative 4x times the fifth root of x is my answer. Okay. 10. I have 2 times the fourth root of 81 times 4 times the fourth root of 16x to the 8th. Here I have a multiplication problem. So again, I'm just going to take the 2 times the 4 first, which would get me 8. Then I'm going to have my fourth root. I want to multiply 81 times 16x to the 8th. If I multiply 81 times 16x to the 8th, I end up with 1,296 x to the 8th power. 1,296 is a perfect fourth, but I need to break up my x's first. So I'm going to move to the right real quick. times the fourth root of 1,296. X to the eighth can be broken into x to the fourth times x to the fourth. So I have a perfect fourth in 1,296. I need to keep my 8 out front. So it'd be 8 times the fourth root of 1,296 is 6. I have 1x to the fourth, 2x to the fourth, so times x squared. Now I need to multiply all that together. So 8 times 6 would get me 48x squared. The final two problems are some of our division problems. Okay. The first thing I want to do with this first division problem is see, can I take 32 divided by 9 and have it come out correct? In this case, I cannot. And you could simplify that if you know how to do it. I'm not going to force you guys to, but if you can figure out how to simplify 32 over 9, it could make things a little easier. But for now, I would just leave it alone. Now, what you'll remember, hopefully, what you remember about a fraction underneath a radical is that I'm going to split it up. I'm going to bring my 9 into the numerator. I'm going to make my numerator into a radical by itself. Then I'm going to make the denominator into a radical by itself. All right. If I keep it now, I'm just going to simplify my numerator real quick. So 9 times 32 is not a perfect square, but it can be broken into 16 times 2. X to the fifth needs to be broken into x squared. That's 2, 4, with 1x left over. Now my denominator, both of those are perfect squares, so you can either change that right now to 3x or keep working because we still need to simplify our numerator. Either way, I don't care which direction you go. Okay? Now what I'm going to do is figure out in my numerator what my perfect squares are. So I have 16. Move down here. I have 9 times the square, the square root of 16 is 4, so I'd have 9 times 4 times 1, 2 x's, so times x squared. That's going to be multiplied by the square root of everything that's left, so 2x. Now my denominator, 9 and x squared are both perfect squares, so 9 would turn into 3. X squared would turn into x. From here, before I even multiply, I can start to simplify my numerator and denominator. So this 9 and 3 would simplify the 9 into a 3. This x squared and x would simplify us into just a single x in the numerator. Now I need to multiply my 3 times my 4 times my x, so I get 12x times my square root of 2x. Okay? Problem 12, I have the third root of 64x to the sixth over 27x to the third. Okay? So I'm going to make my numerator into a perfect cube. 64x, not a perfect cube, I'm sorry, into a cube root. 64x to the sixth. Make my denominator into a cube root, so 27x to the third. 64 is a perfect cube, so I'm going to leave that alone for a second. I need to break my x to the sixth into x to the third times x to the third over the cube root of 27 is a perfect cube, so I'm going to leave that alone, and x to the third is a perfect cube, so I don't have to do anything there. From here, I'm going to go ahead and find my perfect cubes. So 64 is a perfect cube. The cube root of 64 is 4. I have 1, 2 x's, so I'll end up with x squared. Over, there's nothing left in that radical, so I don't have a radical in my numerator. 27 is a perfect cube, so I'll bring down a 3. And x to the third is a perfect cube, so I'll bring down an x. From here, the only way that I can simplify this any further is to get rid of an x in the numerator and denominator. So I'll end up with 4x over 3 as my answer. Well, that is the end of our lesson. The most important thing about this lesson that is not review is the addition and subtraction. What you're going to do is just simplify each piece independently. Once you have the radicals exactly the same and any numbers in front are like terms, you can just add the numbers in front and keep your radical, kind of like if you're just adding with variables. If you have any questions over this stuff, please make sure you come in and see me. Otherwise, thank you very much for watching the video and have a great day.